know the history of things. So origins of some of these identities. So back to the unit circle, which we almost always come back to, y-axis, x-axis, and then I'm just going to pick two angles. So let's pick this angle right here. We'll call that angle alpha. And then we're going to make another angle, let's say over here, and that angle is beta. So notice beta is bigger than alpha here. Doesn't matter too much, but it's true in this picture. What I want to do is I want to find the length of the chord from here to here. Well, that's just distance in Pythagorean theorem, knowing that this point right here is cosine of alpha sine of beta. And this point up here is, oops, no, why did I do that? Sine of alpha. Having alpha beta troubles today. Right, stick with the right angle. And this one up here in red would be cosine beta, sine beta. Right, so we know that the angle of a radius from the standard position here gives us a pair of points, and that point is always cosine for x and sine for y at a given angle. We can apply the Pythagorean theorem to that and find that green length there. Now, I could look at that in a slightly different way because I have made a new angle here. If you look at this triangle right there. So the angle, the central angle in this triangle right here is beta minus alpha. So if I kind of rotate that and redraw it a little bit, so if I just take this angle right here, beta minus alpha, that's going to be somewhere over here. So that angle right there is my beta minus alpha. So I just rotate that whole thing. So I just put the angle in standard position. That a little more clean, beta minus alpha. And then here, that's the point 1, 0. And this right here would be the point cosine of beta minus alpha for the x value, sine of beta minus alpha for the y value. And the chord from here to here, my picture's not that great, but that chord is the same length as this chord right here. I just took that whole thing and I just rotated it. So if we compare with the Pythagorean theorem for the distance here to the distance here, they have to be equal. And if we compare the way those two formulas look, that's where the cosine angle difference formula comes from. So comparing these distances come from the Pythagorean theorem. And I'm not going to go through all the details. Then it eventually cleans up to that cosine. And here I'm writing it as beta minus alpha would be equal to the cosine of beta, cosine of alpha, plus sine beta, sine alpha. All right, so similar to the formula I gave before, I just have alpha and beta backwards in their subtraction. It turns out for cosine that doesn't matter because cosine's an even function. If you're not sure what I mean by even, just a reminder, this is a formula from before. Cosine of negative x equals the cosine of x, which means the cosine of alpha minus beta is equal to the cosine of beta minus alpha. Because when you change the order of subtraction, you just change the sign, right? So that's the same thing. And this right here is the definition of an even function. So a reminder of an identity from before, identity, there we go. All right, let's see, I want to justify one more identity and then we'll just start using these. If I take a look at the angle cosine and the cosine angle sum and the cosine angle difference formula together. So cosine of alpha minus beta is cosine alpha cosine beta plus sine alpha sine beta and compare that with the angle sum, cosine alpha plus beta. Cosine alpha, cosine beta, minus sine alpha, sine beta. In mathematics, we often add equations together. So I just want to look at what happens if I add these two equations together. Notice that really the difference is there's an alpha minus beta here, alpha plus beta there, right? So those are two different functions because they have different insides. On this side, I have cosine alpha, cosine beta, cosine alpha, cosine beta. Those are the same. Here they're the same, but they're different signs. So when I add them, this part right here is going to add up to 0. So part of this disappears. Here on the right side, otherwise I have 2 of those cosine alpha, cosine betas. And on the other side, since these are really 2 different functions because they have 2 different angles inside, the best I can do is say that's cosine alpha minus beta plus cosine alpha plus beta. Doesn't clean up at all, right? So the right side cleaned up dramatically, left side really didn't. However, I now have a sum on one side and a product on the other. And if I rewrite it as cosine alpha, cosine beta, so I lead off with that right there, move that 2 to the other side as a 1/2, that equals 1/2 that sum. So this is that product to sum formula, or one of them I went over earlier. So all of these identities are related, and in particular, they all originate from this one right here, the cosine angle difference, which comes from the analysis of these 2 angles on the unit circle. And then all of these others, the wave shift, the product to sum, the sum to the product, they all come from mixing these together in different ways, adding and subtracting them, multiplying and dividing them. We end up with all these different identities that are useful in different areas. So we're going to next play with using them.